Hello, thank you for watching this video. So on this video I'll be doing question 6 of November 2022 question paper mathematics paper 1. So this is the financial mathematics. So I'll read question 6 and answer the questions that follow. So let's get started. Question 6, 6.1. 12,000 was invested in a fund that paid an interest of M% per annum, compounded quarterly. After 24 months, the value of the investment was 13,459 rands. Determine the value of M, which is the rate, the interest rate. So let me read this statement again. 12,000 was invested in a fund that paid interest at M% per annum, compounded quarterly. After 24 months, the value of the investment was 13,459 rands. Determine the value of the rate, which is M. So you are told, okay, I'm going to split this. Boom. So you are told, 6.1, that a value of 12,000 was invested, right, at an interest of M% compounded monthly. So compounded quarterly. That's what they're telling you. What else? So you're told that after 24 months, the investment is what? Is 13,459 rands. This is what they're telling you. So they want you to determine the value of your rate, which is M there. That's what they're asking you. So you know that, okay, if I invested this amount for this period of time at this percentage and got this, here is my formula. A is equal to P1 plus I raised N. This is what you know, right? So A is your accumulated amount, P was your principal investment amount, and I is your I here. I is equal to your rate, which is M, over your compounding, which is quarterly. That's what I is. Your I is your percentage over 4, because if you're told that your percentage is this a year, is M% a year, compounded quarterly, which means each quarter your investment was gaining interest. Okay, so now you're told that over a period of a year, your investment will be gaining an interest of this rate, right? So that if you are going to get M% gain over a year, right? M%. Okay. So here you are told that the percentage, the interest rate is M% compounded quarterly, which means that over a year you'll gain this interest. You'll receive this interest, but over 4 periods, because you have 4 quarters a year. So that's what they are telling you. So your I here, your I is this, which is that, right? So what does this mean? Which means this is your percentage that your investment will gain a year, M% over 4 quarters of the year, because the year has 4 quarters, right? So over those 4 quarters, your investment will gain that interest rate, or that rate there. So now your I, which is that, is M% over 4, or let's just say just M. over 4. So, what do we do? So you say, okay, I have my A, which is 13,459 rand, which is equal to P, which is 12,000. It's equal to 1 plus I is equal to M over 4. Raised N. What is your N? So, it is the number of times or number of quarters spent by your investment in there. How many quarters did this investment stay there? So, you're told that your investment stayed there for 24 months, right? So, you know, in a year, we have 4 quarters and 12 months, which is in 24 months, you will have 8 quarters. So, this will be 8 here. And then, you want to solve for your M here, so you can have what your interest rate is. So, what do you do? So, okay, divide by 12,000, divide by 12,000. This gone, so we are left with punch this in or maybe you can just leave it out. It's 13,459 over 12,000 is equal to 1 plus M over 4 raised 8. So you take the 8th root here and take the 8th root here. So this side, you'll be left with, this goes away, you'll be left with 1 plus M over 4. This side, you'll be left with, punch this in a calculator. The 8th root of 13,459 over 12,000. So we have 1.0144, right? Then you transpose the 1 to the side. So you have 1.044, or so 1.0144 minus 1 is equal to M over 4. That's what you're left with. You left with M over 4. Then you subtract 1 there. Minus 1. You're left with 0.0144, which is equal to M over 4. Multiply by 4. Multiply by 4. So this goes away. M is equal to this times 4, which is 0 0.5, 0.5778. Then multiply by 100 to get a percentage. So it's 5.78%. It's equal to your M. So your percentage was 5.78% per annum compounded quarterly. That's what that is. So we go to the next question, which is 6.2. I'm going to clean this and do 6.2. Hope this is clear. Okay, 6.2. On January 31 January 2022, Tino deposited 1,000 in an account that paid 7% per annum compounded monthly. He continued depositing 1,000 on the last day of every month. He will make the last deposit on 31 January 2022. Let me read this again. On 31 January 2022, Tino deposited 1,000 in an account that paid 7.5% per annum compounded monthly. He continued depositing 1,000 on the last day of every month, he will make the last deposit on 31 January 2022. So it's clear. So this guy deposited, he made his first deposit on 31 January 2022, and then he continued until the rest of the year, and his last payment was made at the very end of the year, the last day of the year, which is 31 January 2022. So this guy made 12 payments that year. Each of them were made at the end of each month. Okay, what is the question? Will Tino have sufficient funds in the account on 1 January 2023 to buy a computer that costs 13,000? Justify your answer by means of appropriate calculations. So this guy was depositing 1,000 for 12 months at the end of each month. Was depositing this 1,000 for 12 months at the end of each month, 12 times that year. So this guy's aim was to buy this computer that costs 13,000. So they're asking if he deposits those 1,000 at the end of each month for 12 months, and at that interest, which is 7.5% compounded monthly, will he have this 13,000 by the end of the year? So they want to know if he will afford the laptop that he wants to buy at the beginning, on 1st January 2023. That's what they're asking him. So what do? We say, okay, so now what you want to do, we want to find the future value of this investment. So like I said before, so future value, you can look at it in two ways. You can say, okay, the future value formula is equal to x times 1 plus I raised n minus 1 all over I. So this formula here, it assumes that the first payment was made, or it assumes that the payments that are made into the investment account are made at the end of each month. This is what this formula assumes. All the payments that you're making into an account are made at the end of the month for the entire duration of your investments. And then you have this one. A fee is called x times 1 plus I times 1 plus I raised n minus 1 all over I. So this one here, the second one, it assumes that the payments are made at the beginning of each month. So this one, payments are made month end to the investment account, and this one assumes that the payments are made at the beginning of each month for the duration of your investment. But now, in our case, we know that the payments are made at the end of each month, which means the first one is going to work. So this one is month end, this one, month end. So this one is month beginning, if that makes sense. Okay, so in this case, our payments are made month end, which is we're going to use the first one. So I'm going to clean this guy here. Okay, so we know that we want the future value of this investment. X is the amount that he pays into the accounts, which is 1,000 every month. And then I, the rate per compounding per investment period per month, which is 0.075 over 12, right? And your N are the number of payments made into the account. There are 12 of them, because the first one is made at the end of January, end January up to end December. If you can count them, you'll find that there are 12 payments that are made there. So you have all of this. So you can say, okay, now the future value of this guy's investment is equal to 1,000. 1 plus 0.075 over 12 raised n. N is the number of investment periods. How many times did the guy deposit the amount? Which is, he deposited the money 12 times. Minus 1 all over 0.075 over 12. So this is it. So you can just punch this on your calculator. 1,000, 1 plus 0.075 over 12 raised 12 minus 1 over 0.075 over 12. So by the end of the year, this guy will have 12,421 rands 22 cents. This is the money that the guy will have at the end of the year. But the guy needs to, he wants to, on the 31st of January, of December 2022, he will have this money. But on the 1st of January, he wanted to have 13,000. So the guy will not afford that laptop because he needs 13,000 to buy that computer. But he only have 12,400, which means he's short. The shortage is equal to 13,000 minus this amount, 12,421.22. So 13,000 minus this guy, which is, the shortage is 578 rand 78 cents. So no, he will not afford the laptop or the computer. That's what that means. I hope this makes sense. Okay, so I'm going to clean the board and do 6.3. Let's get it. I'm cleaning now. I hope this is clear. Six point 3. Let's go. Tabo plans to buy a car that costs 250,000. He will pay deposit of 15% and take out a loan for the balance. The interest rate of the loan is 13.5%, 13% per annum compounded monthly. Let me read the statement again. So Tabo plans to buy a car that costs 250,000. He will pay a deposit of 15% and take out a loan for the balance. The interest on the loan is 13% per annum compounded monthly. Calculate the value of the loan. So this guy, he wants to buy this car that costs 215,000 and wants to make a deposit of 15% and take out the loan for the rest of for the remaining amount of the car. So he will pay in 15% of the the cost of the car, and then for the remaining amount he will take a loan from the bank. The interest on the loan is 13% per annum compounded monthly. So 6.3.1. Right? What are they saying? Calculate the value of the loan. That's what they wanted to do. Calculate the value of the loan. So the car costs what? 250,000, right? So the deposit is what? Is 15% of this amount. So that's the amount that he wants to deposit, 15% of this, right? So to calculate the actual amount money deposited, so the money deposited is 15% of that amount. So to find 15% of that, it's going to be 15 over 100 times 250,000. Right? So this is 15% of that amount. So the amount that he managed to deposit on the car, let's calculate it. It's 15 over 100 times 250 times 250,000. 15 over 100 times 250,000. So the guy managed to pay up front 37,500. So this is the money that the guy managed to pay. So what is the balance, the money now? So on the 250,000, he managed to pay this, right? He managed to deposit this amount. So what is the remaining balance that he has to take a loan of? So the balance of the loan is equal to 250,000 minus the deposit, the money that he deposited or removed or reduced the cost by, which is minus 37,500. So 250,000 minus this. So the amount of the loan is 212,500. So that's the balance of the loan. So that's the money, that's the value of the loan. So we're done with this one. So 6.3.2. The first, 6.3.2. The first repayment will be made 6 months after the loan has been granted. The loan will be repaid over a period of 6 years after it has been granted. Calculate the monthly installments. Let me read this question again. The first repayment will be made 6 months after the loan has been granted. The loan will be paid over a period of 6 years after it has been granted. Calculate the monthly installments. So they are telling us that this loan here, right? He will start paying it 6 months after the loan was granted. That's what they are telling us. And the loan will be paid over a period of 6 years, which is now he will have to pay the loan monthly for 6 years. That is 72 payments. Sorry, 72 payments. It will be 6 times 12 because each year he will be paying 12. So all those 12 of those 12 payments for 6 years. That is 72 payments in total. So they are telling us, the first repayment is made 6 months after the loan has been granted. The loan will be paid over a period of 6 years after it has been granted. Calculate the monthly installments. So what they are telling you is that the first payment is made 6 months after it has been granted. So they want us to find the monthly installments. So to find the monthly installments of this loan, we use the present value formula for the loan. So the present value formula is equal to x times 1 minus 1 plus I raised to minus n all over I. This is the formula that you use. So what this formula assumes, it assumes, in this case, because this guy is paying monthly, this formula is telling us that it assumes that the first payment is made 1 month after the loan has been granted. This is what this formula assumes. It assumes a first payment is made 1 month after the payment was, the first payment is made 1 month after the loan was granted. This is what this formula says. But in this case, we are told that the first payment was made after 6 months. So now, what that means is, for the first 5 months, so we have the loan, the first payment was made after 6 months. Yeah, after 6 months. After 6 months. So the first payment was made 6 months after the loan was granted. That means that for the first 5 months, the guy was not paying, but the money, which is the loan, was accruing in interest at the time. So you were being charged interest for the first 5 months, right? So the 6th month is the 6th month that he had the money on him. Okay, So on the 6th month, he also had the money on him on that 6th month. But that 6th month is accounted here because here we assume that the payment is made a month after the loan is granted, which means if he didn't pay for 6 months, which means the first 5 months the money will accrue interest, and then on the last month, that month is accommodated in this formula, because this formula assumes that the first payment is made after 1 month after the loan was granted. So it's more like that 1 month is the 6th month now. So now you will have to apply interest on this loan or your balance for 5 months, and then the 6th month will be accounted here, because this one assumes that you will make the payment a month later. So that's how it is. So now the first thing that we do, must check how much will the value be, the value of this loan be after 6 months, after 5 months. So A is equal to P into 1 plus I raised n. A is equal to P, which is 212,500 to 1 plus I. What is your I? The I is 0.13 over 12 raised 5. So the reason is 5 months, because you know they say 6 months later. The 6th month is included on this formula, because this formula assumes that the first payment is made a month after the loan was granted. So now on the 5th month, you must find what the value of the loan after the 5th month. Then from there, the 6th month will be accounted here. So it's 212,500 into 1 plus 0.13 over 12 raised 5. So what is it? So after the 5th month, the value of the loan is 262.53. So this is the value of the loan, 224,262.53. And then now, what are your monthly repayments? So now, because the dude, so in total, this guy is going to pay for 6 years, right? Which means he was expected to make 72 payments. 72 payments over 72 months. But now for the first 6 months, but for the first 5 months, he didn't make any payments into the account. So for the first payments, for the first 5 months, okay. So this guy is expected to make payments over 6 years with 72 payments or for 72 months, right? But he didn't make the payments for the first 5 months, which means now he didn't make payments for the first 5 months, which means now to maintain the remaining period of that from that 72 payments that he have to make is 67 payments or 67 months to pay, because the 5 months is the one that he didn't pay on. Then he started paying on the 6th month, which means now to preserve or to comply on that 6-year period, he will have to make 67 payments, which means this loan now will have to be paid over 67 months. That's what that means. So now we can find the monthly payments into this account. We know the present value is, we are going to substitute on this formula, is 262.53, which is equal to x 1 plus, it's 1 minus 1 plus I, which is 0.13 over 12 raised minus 67, right? All divided by 0.13 over 12. So what do we do? Say this times that, so we have 262.53, which is equal to x times 1 minus 1 plus I, which is 0.13 over 12 raised minus 67, right? So divide by this guy, 1 minus 1 plus 0.13 over 12 raised by minus 67. This side as well, so you have 1 minus 1 plus 0.13 over 12 raised minus 67. So this and that goes away. This side you're left with x. So you just punch this on your calculator. So it's this divided by 1 minus 1 plus 0.13 over 12 raised minus 67. So it's 262.53 times, so should be times 0.13 over 12, which is, you cross multiply it here, so sorry, 0.13 over 12. Therefore your x is equal to 4724.96. So this is how you do this. Yeah, I think this is it. So you are done with this question 6. I hope I explained well.